Zero is my hero.
Welcome to the adventures of Math Girl. With the help of Pocket Ronnie, you also can become a trusty sidekick of Math Girl like PreCalculus and the Daring Derivative.
Counted on our fingers and toes. Now you're here to stay.
Okay, now we're going to be doing polar equations to rectangular equations, okay, using these same relationships. So the one thing I want you to notice is all of our equations will be in r and theta. So we are wanting to look for an r times cosine theta. When we see an r times cosine theta, we can replace it with an x. When we see r times sine theta, we can replace it with a y. If we see r squared, we can replace it with x squared plus y squared. Okay? And again, sometimes these get tricky on how to leave the final answer. Okay? Here we have r equals 1. We don't have any cosine thetas or we don't have any sine thetas, but if we can, in 17a4, if we can get this to an r squared, then we can replace it with something. So how can I make this an r squared? Square it. So if I square this side, then in the rules of math, I have to square the other side. So now I have r squared equals 1. Well, everywhere I see an r squared, I can replace it with x squared plus y squared, and there we go. So now I have it a rectangular equation, and it is in, that's it, we can leave it in that form. That is a circle. The original problem was r equals 1. That's basically saying I have a radius of 1. That's what this is saying too. This is a circle with the center being the origin with a radius of 1. So these are saying the same thing, they're just in two different forms. Okay, we're looking at 17d4, r equals -2 cosine theta. I see I have a cosine theta, but I am looking for an r times cosine theta. If I see an r times cosine theta, I can replace it with x. Okay, I have an r here, but it's not r times cosine theta. So if I multiply this by an r, in other words, if I multiply this side by an r, because in multiplication I can move this right in there, because multiplication is commutative. So if I multiply this side by r, so I have an r cosine theta, then I have to also multiply this side by r. Whatever I do to one side, I have to do to the other side. So now I have r squared equals -2r cosine theta. Well, I have an r squared. When I see r squared, what can I replace it with? I can replace it with x squared plus y squared. Then I have my -2. Everywhere I see an r cosine theta, I can replace it with x. Okay, so now I have that. This is where it gets tricky of how to know what form to leave it in. Okay, if you left it like that, that's not wrong, but it just takes some remembering of some algebra 2 on what form to leave it in. Okay, I'm going to move this to the other side. So I have x squared plus 2x plus y squared equals 0. When you have an x squared and a y squared, when x is squared and y squared, generally what do you have? A circle, if these coefficients are the same, 1 and 1, and they are. So how do I get this in the form of a circle? You have to complete the square with the x terms. So back from algebra 2, completing the square means you're adding a blank there, and whatever you do to one side, you have to add a blank over here. Completing the square, you take half of this, just the x term, not the x squared term, but the x term, take half of that and square it. Half of 2 is 1, and square it, so we have to add that over there as well. Then from completing the square, you factored. Completing the square is called completing the square because it factored into a parentheses squared. Whatever you wrote there, 1 squared, that's what goes right there. So x plus 2x plus 1 factors into x plus 1 squared, because x plus 1 times x plus 1 will give you that trinomial. And then I still have my y squared equals 1. 0 plus 1 squared is 1, and that is in the form of a circle. The center of the circle would be -1, 0, and then the radius would be the square root of that, which is 1. So I know it gets tricky on trying to remember all these things. Alright, let's look at 17d6. Okay, so this is in a polar equation, so we want to change it from r's and thetas to x's and y's. I'm trying to look for r sine thetas and r cosine thetas, or r squares. So these are kind of like playing chess or checkers. You have to look ahead. So I have a sine theta here and I have an r here. Can I get these together to where they're multiplied together? If I took all of this and multiplied it to the other side, then I would be multiplying r to everything, and then I would see that I would have r times this, okay? So I'm going to get this out of the denominator and multiply it to the other side. Okay, so it cancels over here. So basically I have 1 minus 2 sine theta times r equals 4. Well, this r can get distributed to everything. Okay, so then I have r minus 2r sine theta equals 4. Okay, the fact that I already have an r sine theta right here, I'm going to go ahead and change it to a y. So I have r minus 2y equals 4. I can't leave it like that because I can't have r's and y's together. So I'm going to move this out of the way to the other side. Okay, so I have r equals 2y plus 4. Now if this was an r squared, I could change it into x squared plus y squared. Okay, so if I square that, then I have to square that side. Okay, so now this becomes r squared. I can now replace it with x squared plus y squared equals, I'm going to multiply that out. That would be 2y plus 4 times 2y plus 4. So x squared plus y squared, this is the question of how far do you go and how much do you simplify it. So that would be, sometimes it's hard to know. 4y squared, that would be an 8y plus an 8y, so that would be 16y plus 16. So now I can see I can get my y squares together. So, and it is hard to know what form, what to leave this in. So all I'm going to do is just basically move this over and get my y squares together. And that's all, and then I'm just going to leave it like that. So I'm just subtracting that. Yes, is this some sort of, this would probably be some sort of ellipse because my x squared and y squared are, my x and y are both squared, but my coefficients are different. So I'm not even going to worry about putting it in any kind of ellipse form. So here I'm just going to leave it as x squared equals 3y squared. And if your form is not exactly like the books, don't panic too much if you can tell that the answer is right. So you could have put it in the form, you could have put everything on one side if you wanted to. You could put it in the form of 0 equals 3y squared plus 16y plus x squared plus 16. So the main thing is just to know that you have all your terms in there.